Having worked with many companies over the years, in 14 years, some very interesting things happen in the area of metal forming, die protection, where sensors are concerned. Things get a little hairy when it gets to sensors because our process variables are all over the map. We have stamping presses of every vintage, every brand from all over the world. We see press controls from every vintage imaginable to no press controls. We have people who don't know what a sensor is. We still have coat hangers looking at long feed, all kinds of stuff, right? So getting our arms around these things, just finding beginning points has always been a challenge. The process variables are all over the map. On the flip side, when we look at people who do robotic automated welding, our process variables become very predictable. And we'll see here in a minute, only 3 things happen in a weld cell where sensors are concerned. We nest parts, we locate parts that are going to be joined regardless of the welding process, whether it's MIG or TIG or helium arc plasma laser. It's very predictable. We look at clamping position, either pneumatic, hydraulic, or with power toggle clamps. And we poka-yoke. So we look for certain features and validate the towers or nuts or flanges are present before we do the welding process to deliver a perfect part to a customer. It's very interesting. I'm called in on applications daily. Customers also call and say, give me your cheapest price on these sensor parts, 12, 18 millimeter procs, whatever, I need the cheapest price. And then you go further and say, why do you need the cheapest price? And it always comes down to this: the consumption is so high, we burn through so many sensors that we can't get our arms around it. Let's just get for the lowest price. We'll get our change out down to 30 seconds, and this happens all the time. And these big consumers. My largest customer that I've worked with burns $70,000 a month in connectivity and inductive or photoelectric sensors that might be present in a weld cell. So we've been living in a paradigm of sorts by fixing the same problems over and over again. We're worried about price and supply chain management, delivery and stocking of parts. And it dawned on us a couple of years ago, wait a minute, we're all missing the boat here. The problem isn't necessarily with the sensor. It's the way they're mounted. It's how they're bunkered, just like in metal forming. If you put a sensor in a die properly, just as George Karamedja professes, he's absolutely right, it will outlast the die. Because the mean time before failure in an inductive prox is over 100,000 hours, just under 14 years, if it's used under stated conditions. So we're living in this repair mode and stocking. People are putting vending machines. I don't know if you've seen those things. Let's put a vending machine in, and we're asked for it daily to get parts out for replenishment. And then we say, wait a minute, what is this costing in terms of downtime? You'll see some statistics here. Many of the companies we work with, they assign it anywhere from $250 to $1,000 a minute downtime in welding cells. I just got back from working with a company in California. One cell, a major product for an automotive manufacturer, 320 minutes of downtime in 1 quarter. And that's $605 a minute. That's a lot of money. So we said, wait a minute, here's what we got to do. We've got to address this paradigm, and the paradigm is welding, where sensors are concerned, equals high consumption. It means a lot of material cost, and we're automatically going to have unplanned machine downtime, so we have to get our replacement down to a very, very short period of time. That's the paradigm. So we got our arms around this thing and really addressed what's the root cause of failure. The root cause of failure is the folks who build the weld cells. When we approach them with this technology of bunkering and putting the right application-specific sensor in the right spot and every location for the type of welding that's being done, there's only one thing they seem to be interested in: it's cost. They don't necessarily get a brand specified from a sensor provider, but rarely do they look at what needs to go in every cell location, considering parts loading, weight of the part, type of welding that's being done, what's happening in that process. So we automatically get this equipment to the customer, you do PPAP or runoff, and after that, you live with the residual. And we end up with a storeroom full of a mishmash of sensors. We grab the wrong ones, we have to keep these huge inventories, and we're in a mess. So, stepping backwards, you said, wait a minute, here's the best way to approach this. Let's reverse the paradigm and look at root cause of failure and fix the problem first before we get into the supply chain management situation. And that's really the whole essence of this program. So we'll move through this. Again, this is just looking at the parts in the right nest, the right location. This is all that happens. And there's a good example of a switch. You can see these plastic brackets. In many welding situations, these things vaporize in weeks. Where we have oil, we have impact, we have all kinds of things. But anyway, that's a typical nesting sensor, parts presence in a typical MIG cell. And next there are clamping indication, either pneumatic or hydraulic or with a power toggle clamp. You've all seen those from many different manufacturers. And there's a typical tie rod type system. Actually, that's a pretty good one from a company out of Tennessee that does a pretty good job of mounting and guarding and protecting. That's typical pneumatic. Here's a embedded high pressure proximity sensor. It looks at the spud of the piston moving by for end of stroke position for clamping. And these are pretty robust. They're rated at 3,000 psi. They're all well field immune. The sensing element is way down in the cylinder itself. It'll withstand burst pressures at 10,000 psi. It's pretty well hidden from the hostilities. And here's a typical power toggle clamp. Our sensor elements are hidden well inside the clamp, and there's rods that move back and forth that indicate clamped and unclamped position, and it's pretty well bunkered from the elements. And our air proofing. Here we wanted to validate that this particular flange is present. It's very important. If it's missing, it won't work in a truck frame. We can't even build a truck. You can see the hostility. It's bad. Have all you witnessed this kind of stuff before? It's a mess.